Hi friends, welcome back to the channel. In this video, I want to talk about shift and rotate in Codesys. If you follow my TIA portal tutorial, we have already used shift and rotate in TIA to simulate the bottle filling line using ladder logic. I've noticed in comments that most of you like such projects, so I decided to do this project this time in Codesys using structured text programming language. Let me first explain how shift and rotate work. As you know, the binary format of 5 is 101. If you want to store this value in a byte in PLC memory, it would be like this. Now if we want to shift all bits one bit to the right or left, how we can do that? For example, if we move all the bits one to the left, we will have this value. Each time with shifting, 0 will be added to the first bit from the right. The new value now is 10 in decimal. Or if we shift the bits to the right, the last 0 comes from outside and 1 that was in the bit 0 is shifted now by 1 to the left. In fact, it will be deleted and the new value is now 2. So we can shift these bits to the right or left and change their position. But as you see, when a bit comes to the end of the right or left side, with another pulse it will be shifted outside and it will be deleted. Sometimes we need these bits again and we don't want them to be deleted. In this case, we can use rotate. Rotate is exactly like shift, but the bits which go to the right or left are not deleted and they come back to the extreme left or right. Same thing we can do with Codesys. Open the main program. From the general, insert a box. Write here the name of the operator that you need. Let's start with a shift to right SHR. I'm going to declare start as enable of the operator. Shift right will shift the content of the first input bit by bit to the right. Second input determines the number of bit positions by which the value is to be shifted. The result will be stored in the output. Let me define inputs and output. Now with each pulse of enable, bits of the input byte will be shifted one bit to the right and stored in the output byte. Use a trigger to shift the input when we activate the start just one time. I'm going to copy this network to show you other shift and rotate functions. SHL shift to left and rotate to right, rotate to left. Declare say more outputs and triggers. Simulate the program. Log in and start. Write here to the prepared value 5 for the input and true for the start. And then write the values. As you see, 5 is just one time shifted to the right or left. Here the input is always 5, so with another pulse the output will remain the same. To shift the input once again with another pulse, use the input byte in output. Let's declare 3 more inputs. Now with each pulse, you can shift or rotate once again the input value. Download the changes. Write again 5 for the inputs. Activate the operators. Now with each pulse, the input 5 is shifted, and that's how shift and rotate with every single pulse work. Now let's do the bottle filling project with shift operation and using structured text. The most common application of shift in the real world and industrial project is a shift register, where you have, for example, a machine with some levers or steps that each one is considered as a bit. For example, here we have a bottle filler with 8 filling nozzles filling the bottle with 2 different sizes, 200 and 500 milliliter. Each filling station is considered as a level or step, so we need to track the bottles to know their size and position and fill them according to the size. Imagine these 8 filling places as data bits of a shift register. When the size of the bottle is 500 milliliter, we consider the data bit as 1 and 200 milliliter as 0. Now we can use a height sensor to detect which bottle is 200 milliliter and which one is 500. First we have a big bottle. The height sensor detects it and gives 1 as the output. With starting the conveyor, bit 1 will be shifted. Next we have a 200 milliliter bottle which gives 0 from the height sensor. Similarly, the data bits in the form of 1 and 0 are being entered into the data register and shifted right with each new bottle. In the end, based on this information, we can create the shift register and we know which bit is 0 or 1. In this way, we can track the bottles and fill each one correctly. Let's create our program in Codesys. Create an empty project with ST as the programming language. To save time, I will cut the video several times. First, we need to detect big and small bottles, so declare a variable for sensors and bottles. When the height sensor is false and the second sensor is true, it means we have a small bottle. And when both are true, we have a big bottle. With each bottle, the program gives you 2 seconds, and after that, the conveyor starts for 4 seconds to move the bottle to the next station. So declare a TON timer. A big or small bottle will activate this timer, and another timer for the conveyor. I've used a counter to count up the bottles. We have 8 stations and our register is 8 bits. So with the 8th bottle, the counter will be reset. After 8 bottles and after 6 seconds, the filling will be started. We need a TON timer for 6 seconds wait. and the TP timer for filling that will take 8 seconds. 6 seconds is 2 seconds for waiting for the bottles and 4 seconds for the transition of the last bottle to the filling station in this part. We need the following trigger to reset the counter when the filling is finished. Use the output as the reset of the counter. As you know, when we shift the bits to the right, 0 will be added from the left. But when we have a big bottle, we need to add 1 to the first bit from the left. We need this just when we have a big bottle, so we should declare a rising edge to add this number with each big bottle just one time. When the edge is detected, 1 will be added. I'm going to declare a byte variable for our shift register. Write this attribute to see this number in binary format to understand better how shift here works. In this way we can do this. 80 in hexadecimal is equal to this number in binary. Next we need to reset the shift register when the filling of 8 bottles is done. So when the filling is finished and with falling edge, 0 will be moved to our register. And stop the shift operation when the number of bottles is 8. With an if statement and using a counter current value, we can do this. Now with each pulse of bottle detection, if the number of bottles is not 8, the bits will be shifted to the right. For the big bottle, we have already declared a trigger. We need another one for a small bottle. If you have one of these edges and the stop shift is not active, then it is allowed to shift the bits to the right. When a bit of the shift register is 1, a long filling with 8 seconds will happen. If the bit is 0, the filling will be 4 seconds. So we need another timer for short filling. And finally, filling statements. Nozzle 1 will start to fill 8 seconds if the filling start is active and the first bit of the shift register is 1. This bit we can use in our program with a point and 0, bit 0 of the byte shift register. It will fill 4 seconds if this bit is 0. Copy this for the other 7 nozzles. Let's start a simulation. I've also created a visualization to see the conveyor motor, shift register, number of bottles, and nozzle filling. The first bottle is big. After 2 seconds, the conveyor will be started. The shift register is now changed. 1 is shifted to the right. Next is small. And then again, a big bottle. 2 small and 2 big ones. And the last one is small. In the end, we will have this shift register. The big bottles with the value 1 will be filled for 8 seconds and the small ones just 4 seconds. Shift register and counter are again 0. Let's do it again. Big, big bottle, two small bottles, big and small. And again, big and small bottle. According to the size of the bottles, nozzles are filling for 4 or 8 seconds. Alright, this was a simple example of using a shift operator in the codices and using ST. Based on your requirements, you can change some parts and use it for yourself. I hope this video could help you improve your programming skills in Codesys using structured text. See you next video, friends. Bye.